webinar hosted by ABB Energy Industries, and we're joined by Hyperion Systems Engineering, software provider of HIPOS, and Hellenic Petroleum, and we're going to discuss ways to use digital twin technology to solve some of the biggest challenges in polymer production today. So very pleased that you've been able to join us for this presentation. A few housekeeping things first. So Simeon, if you can help by just moving us on one slide, please. Thank you. So we'll have the opportunity to go through a Q&A. The way that you do that is to please submit questions into the Q&A box that you should see in your panel. Just a reminder that all attendees are on mute and will remain so throughout the duration of the presentation. And this event is being recorded, so there'll be an opportunity to review that later and also to send that to your colleagues as well. And if you could, yeah, just move us on. Thank you very much. So in terms of the presenters during today, so I'm moderating this session. It gives me great pleasure to do so. I'm the Digital Technology and Innovation Lead for ABB Energy Industries, based out of the UK. And I'm joined by colleagues from companies that have joined us in this presentation today. So from Hyperion Group and also Hellenic Petroleum. So I'm joined by Simeon, Simon and Nikos, and I'll just ask each of them to please turn on your camera and just introduce yourselves for a few minutes. So Simeon.
Yeah, thank you, Will. I'm Simeon Kassianidis, and I'm the founder, CEO, and chairman of the Hyperion Group. I'm a chemical engineer with a bachelor's degree from MIT and PhD from Imperial in computer applications and chemical engineering. And I have now more than 30 years of experience in working with the process industries globally in the implementation of advanced solutions. Simon?
If you're on mute. I'm Simon Doe. I am software architect at Hyperion Systems Group. I have a degree in electrical and electronic engineering from the University of Hertfordshire. But professionally, I've been designing and developing applications for the chemical engineering industry in simulation and control for over 40 years. And I have spent the last 8 years working specifically on polymers, developing the HIPOS technology.
Nikos?
Hello, on behalf of Hellenic Petroleum Group, I would like first to welcome you to this webinar. As said before, I'm Nikos Perperis. I'm chemical engineer, and for the last 5.5 almost years, the polypropylene production manager. I started my career in Hellenic Petroleum as production engineer. The process department for chemicals plants, and then back to polypropylene plant as the manager. I had also a short jump to the safety and health department, and I started my career in plant producing fittings and pipes from PVC and polyethylene. So all my career has to do with industries with polymers and plastics. Thank you.
Fantastic. Thank you very much to everyone to join us. So yeah, we've got a very lively presentation today. We're going to outline the need and importance of the predictability of product quality in order to drive efficiency. We're going to address some of the current best practices in the chemicals industry, and then share insights from recent case studies, including from Hellenic Petroleum. And then we're going to describe the state-of-the-art proposition of the HIPOS solution throughout as well. So from this moment, I'll hand over to Simeon to then take us through the main bulk of the presentation. So away you go.
Okay, thank you, Will. So, all right, I will start by giving a few words on Hyperion. The company was founded in 1993. We provide technology and engineering advisory and implement advanced solutions in the hydrocarbons, chemicals, and power generation industries. We implement systems for planning, scheduling, MES, simulation, optimization, advanced process control. We do that globally around the world. To date, we have delivered more than 500 such projects across 51 countries. So turning to the focus of the discussion today, we developed our first polymers material tracking solution in 2004. As more bespoke solutions were being developed, we introduced quality tracking together with material tracking in a number of facilities. However, each project was bespoke and required significant effort from both Hyperion and our customers. So then in 2018, we decided to capture our knowledge and experience into a product that will enable the easy configuration of solutions that provide effortless real-time process tracking and analysis, saving product time and money. So today at the agenda, we will start by discussing the current challenges and best practices in polymer production. Then we will present our proprietary technology. Hellenic Petroleum was our launch and is our launch partner, and Mr. Perperis will talk to us about their user experience. Finally, we will introduce current R&D activities in AI and machine learning, aiming at enhancing the decision support features of our solution. We will then close with a question and answers Q&A session. So let's focus more on the polymer production. So plastics are an essential part of everyday life. However, we are all aware of the attention the industry receives, especially from an environmental viewpoint. So reducing the carbon footprint of plastics manufacturing is an important challenge. A second challenge comes from the fact that polymer production can be a combination of continuous and batch processes, and this makes quality predictability and raw material tracking and traceability a big challenge, which in turn makes achieving and maintaining operational excellence difficult. However, as we will show, it is possible to provide real-time actionable information that can lead to sustainable operational excellence. I'll now turn on to Simon, and Simon, please, I'll go on mute and you can continue from here.
Thank you, Simeon. So let us now look at the challenges that face the polymer industry. As we said, this is a continuous process with some batch aspects. The real-time tracking of material, both in terms of what is in the product and where it is now within the process as it moves along the equipment, followed by the quality being tracked in real time. The issue being, if we detect a problem early on in the process, such as in reactor 2, in 2 hours time, where is it now? It will be somewhere along the production stream, but where? The next issue is detailed product history, which covers what is in the product and the details of when and where it was made during the process. And then we have the predictability of quality during grade transitions. Obviously, this helps speed up the transitions between different grades and reduce the production of off-spec material or transitional material. We then can move into the time characteristics. Because of the nature of the process, it takes hours to go through the reactors and then hours to produce enough to fill a batch. So a batch might typically take 8 hours or more. And we have the laboratory taking measurements, and the test results are often an hour or so behind when the sample was taken. This results in delaying decision making because you don't know what it is until it's already been out for an hour. To achieve operational excellence, we have to minimize the production of off-grade product and, as a consequence, wasting raw materials and resources. and both of these impact CO2 production. We move on, Simeon. Next slide, thanks. Current solutions do not directly address the challenges outlined earlier. Solutions can be created but require excessive custom development. The exact nature of this varies depending on the chosen platform. A classic problem with quality testing is that the results are delayed while the lab performs the tests, and sometimes by an hour or more, as we illustrated earlier. And this impacts the decision-making process. As the bulk of the process is continuous, if a quality issue is detected at an early stage, there is no visibility of where the affected material is an hour, 2 hours, or 3 hours later. We move on, Simeon. Is that the right way? Oh, sorry. A little background on HIPPOS. The technology has grown out of knowledge and experience gained from projects executed over the last 18 years. The solution is not specific to polymers and can be applied to industries with similar process behavior. To make the technology easy to apply to different processes and working practices, it has been created using standard components that can be arranged to cover most requirements. Custom models can be easily added to handle specific requirements. The HIPPOS system is composed of 3 main modules, which are the digital twin, which tracks the material in the plant, the workflow, which automates procedures and background tasks, and finally the web-based displays and reporting. So HIPPOS is positioned within Industry 4 as a deep tech decision support tool within the tactical management level. And it collects data from systems at the transitional management level, from the plant, controls values, etc. Feeds and receives data from systems at the strategical level, e.g. SAP, and coexists and interacts with other systems such as LIMS at the same level. We now look at each of the components of HIPPOS, starting with the digital twin. This replicates the main process equipment, delays, holdups, and material movements driven by measurements from the plant. As the material moves through the process, it can be tagged with quality and other information as it passes instruments and sensors. So it carries that along with it. The software maintains a detailed history of all movements of material between vessels and into the final product, allowing creation of detailed reports of how and when the product was made. The digital twin is constructed from blocks that replicate the main equipment as shown in a P&ID, and by then adding the live process value tags from the plant. So, yeah. The second active component is the workflow module. This implements the interactive workflows for standard operating procedures, as well as automating background monitoring tasks to detect and action specific events. The workflow typically execute a sequence of steps transitioning to the next based on specific conditions. When the workflow interacts with operators, the screens are only visible to the operators with specific roles, so nobody is distracted by something that's not relevant. A real workflow, unlike the one illustrated, has more paths to handle non-standard operating situations, and typically these will require approval steps to allow the operation to proceed. The reporting module converts the collected information and presents it in meaningful forms for each role. The module includes 8 standard report groups, which can cover different time periods, that is daily, weekly, monthly, yearly, etc., giving a total of 40 or more different reports. Available additional reports can easily be added to cover any plant-specific requirements. So the benefits of HIPPOS are that it collects data from multiple sources, extends it using the digital twin, and creates a single unified view of the process that can aid decision-making process. To summarize, improves decision-making process by giving visibility of critical information, concentrates fragmented data from multiple sources and provides a single overall view, improves collaboration and efficiency, improves product quality monitoring, improved plant operations visibility into raw material consumption, addresses regulatory concerns providing traceability, and higher yield in less time leading to higher profit margins. Which leads on to you, Simeon.
Yep. Thank you, Simon. Okay, so to summarize, and then to bring all these points and discussion, I think we're focusing into how digitalization can benefit polymer production. And we've seen in practice that manufacturers can increase the differentiation and competitiveness. They can achieve significant efficiencies and cost reductions. On this, I would like to refer to a recently published report indicating benefits of up to 20% reduction in batch cycle and 40% reduction in product release time. And last but not least, the digitalization can help plants achieve their sustainability targets. We all like to look at numbers, and so just as a teaser rather than something specific to get everybody thinking of the magnitude of the potential benefits of using this technology or technology such as this. In the event of recovering 1,000 tons of off-grade material at a cost of 1,500 euro per ton, and that might be outdated the number, the material cost saving would amount to 1.5 million euro per year. And in a plant of 250 or 300,000 tons, you understand the impact of such efficiencies. On top of that, we have the carbon pricing, which is an additional benefit. So while the reduction of greenhouse gas emissions from improved operations can improve the ESG score and rating of the company. With this, I will introduce now, and I will pass on to Nikos Berperis, the polypropylene production manager of Hellenic Petroleum, for his part of the presentation. Nico, the floor is yours.
Can you hear me?
Yes, we can hear you now.
Okay. Sorry, but there was a problem with my connection. I hope that I was not. Let me first introduce to those who may don't know the group Hellenic Petroleum. Hellenic Petroleum is a dynamic group, the biggest in the country, having a leading position in the Greek energy sector, as well as in the greater area of Southeastern Europe. The group's range of activities includes supply, refining, and trading of petroleum products, both in Greece and abroad, fuels marketing, both in Greece and abroad as well, petrochemicals production and trading, oil and gas exploration and production, power generation and natural gas, renewable energy sources, provision of consulting and engineering services to projects related to hydrocarbons. Hellenic Group is active, as referred before, in Southeast Europe, being one of the key marketing players, having a network of almost 300 stations in several countries as Cyprus, Bulgaria, Serbia, Montenegro, Republic of North Macedonia. Coming back to petrochemicals, Hellenic Petroleum is the only producer of petrochemical in Greece, having a market share exceeding 50%. Export activity is particularly important, representing approximately 70% of petrochemical sales volume. Coming back to petrochemical now, again, and to the polypropylene plant. The polypropylene plant runs under spherical technology developed by the ex-Basel, now LyondellBasell, with a capacity of 240,000 tons per year. For the time being, 14 grades are produced. However, new grades can add to our portfolio. Okay, Simon? As we all know and experience, the fourth industrial revolution has already invaded in our lives and transformed businesses worldwide using the advantages of modern technology. Helpen, of course, as a leading company, could not stay away from this transformation and has adopted numerous actions that you see in the list shown in this page. Some of these actions are completed and already run, some are still in progress. The Hyperion HIPPO solution has piloted and has since been deployed at the polypropylene plant, and it is one of the main actions for the digital transformation of the polypropylene plant. Next page, please. The beta testing, installation, and launching partner. Hyperion selected Helpen as the launching partner for HIPPOs due to the high suitability of Thessaloniki plant, the opportune geographical proximity, as well as the long and historically successful cooperation between the two organizations. Configuration and installation was completed 100%, and this is very important for Hyperion, remotely due to COVID-19 pandemic outbreak. The beta testing was successfully completed between May and June 2020, 2 years ago. Since July 2020, HIPPOS is connected to the real-time plant data management system, collecting data from the PP production line to track production batches in real time and produce the associated reports. But what is all this job for? Just show a bit the previous page, please, Simon. Okay. As we can see to the down right part of the page, the plant has one extruder line, 6 blenders, 4 bagging silos, and 23 silos dedicated per product. Why is this that much important? We have to tell that, and this is connected to the benefits of the HIPPOs to our plant. Now we can go on with the next page, please. Here we are to the benefits. We will see some of the benefits, although we will be able to see and detect them to the next pages, to the following pages. So let's explain first that the plant somehow has 2 distinct separated areas, the reactors area and the area of extruder and then the silos that we have seen before. In both areas, the process is continuous, but it is at the extruder area and after it that the separation of the batches takes place. So this is what was said before, that it is the integration between a continuous and a batch process. And this is the main benefit that we can have from HIPPOs. So all continuous production history, reactor and extruder areas, the 2 areas that we have just said, is now associated with the final batch product in real time and available online. It offers a single consolidated source of information within a specific product batch, spanning across the full production cycle, continuous and batch. Through the provided material tracking, it enables the immediate troubleshooting of production issues and the investigation of any customer complaints and claims. Online monitoring and real-time calculation of raw material consumption, for example, monomer, catalyst, extruder additives, enabling the end user to maintain good product quality on spec, as well as monitoring the associated production cost. And it allows the real-time and online monitoring of production by a range of users and managers at all levels, facilitating the single version of the truth. This eliminates the need of the manual preparation of reports by the process engineers or LPS manager, which may be prone to errors. Therefore, TIPOS increases collaboration and it makes more effective. Let's go on now to see the reporting. Here we can see some of the reports that HIPOS can prepare for the plant. We can see, and as a matter of fact, we have to tell that we are still develop HIPOS, and every day we have a new idea. Every day with the colleagues in Hyperion, we can add new reports according to our needs and according to what we want to withdraw from to draw from this from the plant and from the system. The first one that we see is the batch summary report, which is the most important, I would tell, because we have all the details from the production of the batch. The same, it is the second one, detailed batch report. The additive report, where we can see if all the additives to the extruder area have been added correctly, which is very important for the final quality of the product. So it eliminates the off-spec product. The grade daily report, quality reports, scrap details report, scrap monthly report, downgrade report, production KPIs. This is very useful as well for all the managers, from the manager from all the level, that they can see our KPIs. And the final detail production report, which is quite rich in items that we would like to see. Okay, Simon. I don't know if we can see quite well this page. Here, it is the integration of what we said before of the continuous and batch process. Here we have the several, this is the formation of a batch, which we can see the time of collection of this batch and the several stages that this batch had to pass from. These are real times that have been designed by Hyperion, and we can see all the process and the several raw materials. We will see them later. The several raw materials through the production, through the process, through the reactors mainly, and then we can see. May we go on a bit? Yes. And there we can see where finally this batch has gone. We can see it to the silo that was dedicated for this batch, and we can see to the down table the several materials and additives and the quantities of it. From here, we can have a very good picture of the quality of these batch, and in case something hasn't been added correctly, we can see it during the production of this batch, which is very important, of course, because as we said, the benefits, one of the benefits and maybe the most important is that we can detect any mistake during the production, something that goes wrong during the process at real time. So having all this info, we can rearrange and fix our parameters in order to go on having an on-spec product. Okay, this is just a report. This is the final report of the batch that we see all the parameters and all the materials that we used. But all these are investigated and checked during the production. To the down part of this page, we can see the batch quality report. We have a different quality report, but we can have as well an idea from this page as well. Simeon, please. Here are the main parameters, quality parameters that we have to check and to decide if the final product of a batch is on spec or not. As I said before, and I repeat again and again, this is something that we can control during the production of a lot. And this is just the final report. These are all the parameters that our lab can check and give the certificate for a batch. Okay. So I have already said that we every day think of new things and we add new items in Hyperion, in Hippos. So we have already planned for the future some extra job to do. And as a matter of fact, there are some ideas that I haven't yet referred to Hyperion. So it means that we will go on our collaboration. Let's see some of our future plans. Test and implement the machine learning algorithms, which will, test and implement the machine learning algorithms for the prediction of MFR, melt flow rate, melt flow index, where online polymer analyzers are not present. This is the MFR is one of the main parameters that we have to check for our product. So it is very important. This will allow the online monitoring of quality during the production process, enhancing decision support. Integration of Hippos with SAP system. This is also something that will eliminate a lot of our time that we spend in several programs. Expand the Hippos scope to cover the supply chain from the orders of product and raw material to the post-delivery and distribution to end customers. Integration of Hippos with the orders warehouse management, sales and logistics systems to achieve a complete and integrated ERP environment. Speaking about these two bullets, I would like to tell that, of course, we can monitor all these things right now. I mean, the orders, the sales, etc. But we can do it using not only one software. With Hippos, all the departments having to do with the production of the polypropylene will be able to have a view of what happens from the order of the raw materials till the final user, just watching HIPPOs. Integration of HIPPOs with the operators rounds and operators logbook. This is something that will take place in the next months. It has to do with digitalization of the company, of the plant. And we are going to write down everything through tablets out to the field. And all the supervisors will have a logbook. And these tablets and this logbook will be connected to HIPPOs. So all the infos having to do with measurements taken from the plant will be automatically appeared in HIPPOs. This will make things much better for the quality, as we will be able not just in real time but in seconds to go out to the field and see what goes wrong. One of the future plans as well is to have a better energy management, and one that it is not written here, it is to go on our cooperation with the preventive maintenance, putting in HIPPOs all the maintenance programs that the several maintenance departments have, and so we can have a quick look to what we have to do. That's all from my side. Thank you.
And just before we continue, we can just jump in here to remind all the audience just to submit your questions into the Q&A box that appears in the panel of your application for WebEx. So yeah, please submit your Q&A and then we'll run through some of those just shortly as we close up the presentation.
Thank you, Nico, and thank you, Will. So to summarize, as a closing statement here, before we go to describe a little bit our machine learning and AI R&D activities, HIPPOs is an all-in-one decision support tool, easily configurable, that integrates production and business management level IT, and enables timely intervention and corrective actions in operations, at all time maintaining a single version of the truth in operational data. So we have discussed the, in the closing section, we would like to introduce the current HIPPOs related activity for enhancing the abilities of the system. We recognize that, let's say, in a number of facilities, the availability of instrumentation, especially for online polymer analyzers, is not as widespread as may be thought. So in order to have the online quality predictions in real time and be able to take even further actions, we decided to explore developing machine learning algorithms that could then lead to soft sensors that can infer process readings in the polymer process when in the absence of instrumentation. We did work on the backbone of using data from the polymer plant of Hellenic Petroleum, and we worked with the Cyprus Institute under the EuroCC framework, let's say for high performance computing, in order to develop this technology. Our findings are very encouraging, and we're coming close to the possibility of trying, as Nikos mentioned before, to maybe put online and start testing. And with that, I'll put on to Simon to just say a couple of words. And Simon, over to you.
Thank you. So as we've just said, last year we completed the research into predicting the quality indicator parameter MFR from live process data. We've chosen the machine learning approach over a dynamic model, as it's going to adapt automatically to aging processes and changing of catalysts and other parameters. The dynamic model approach keeps needing to be retuned, so that's not very appropriate. For this project, MFR prediction was for the base polymer as it exits the reactor stage. We didn't look at the post extruder. And the research trialed many different AI and machine learning approaches, and the idea was to try and identify the most appropriate approach of these techniques. If we move on to the next slide, Simeon. Thank you. This graph shows the most successful of the approaches we conducted. It illustrates that predictions for the low MFR values are very good. We quote something like 98% there. It also highlights limitations. The high MFR values are slightly more inaccurate, but we're now working on new methods to address this and other limitations to improve accuracy for all MFR values. So that concludes where we're going with this.
Thank you, Simon. So I think with this, we have now reached the end of our presentation. I hope you found it all interesting, and I'll pass on to Will for any Q&As, any questions that may have come through.
Yeah, thank you very much. Really informative presentation there. So thank you to all the speakers. So first question in here is, I guess there's lots of instruments and sensors that are required to provide the data points needed for the system. But so how do you deal with that when plants maybe don't have a great deal of sensors and instruments already in there? Do you have to put in that infrastructure?
Simon?
For the digital twin, we work around what they've got. We don't mandate that they have to put things in.
Okay. Yeah. Is there kind of a minimum that's required, Simon, or?
Well, this is always a challenge when you go to a real plant. You don't have the ideal instruments always, so you have to work around what you've got.
Yeah.
And they always have enough instrumentation to run the plant, so we work on that basis. We haven't encountered something we couldn't cope with yet.
Okay. But I guess, would you recommend to add more after an implementation if it's going to lead to kind of additional data points that are useful to you or something like that?
Yeah, that's the case. If you start finding you want to do things that aren't working very well, then you start looking at maybe improving your instrumentation.
Okay.
In particular, flow meters are not very good with polymer powders.
Yeah. Okay. And you mentioned polymers specifically. So are the particular, there are lots of different types and grades of polymers. So someone here is asking if it works particularly kind of or better with certain grades or types than others, or whether it can work, well across them all.
That's a good question. We've implemented it on plants producing different types of polymer. We've done LDPE, HDPE, LLDPE, polycarbonates, and polypropylene, obviously, which is the halpane. And we found it works pretty much the same on all of them. Yeah.
Okay. And going back, so someone's asked a follow-up question to the sensors one, so I think we should take that now. So is there potential, or is the possibility to use the AI function even without so the sensors? So if enough data sets are taken into consideration, maybe without additional data, from sensors themselves. So to read that question again, is the potential for the AI to be able to function even without additional sensors if there are enough data sets taken into consideration?
Yes, that's the objective. That's specifically the objective.
Yeah.
We recognise that not everybody has all the instruments, so particularly not automated analyzers in necessarily all the places you want. So this is exactly what this is for.
Yeah. Very good. And someone's asked a question about kind of, I guess, system integration. So lots of different software exists already within plant infrastructure now. So can HIPPOS be integrated within that kind of existing software architecture, maybe where software like, I might be pronouncing this incorrectly, but Braumat or Bromat is used already?
Not specifically come across that one, but we have the ability to create interfaces to most things.
You've probably not come across my pronunciation of that one, Simon. You've probably come across.
I don't think I don't recognise the name at all.
Okay, very good. And so, what specifically we talked up front, and it's been kind of a common thread through the presentation, but about kind of sustainability, impact, quality, things like that. But can we kind of talk tangibly then about the solution helping to improve or reduce the environmental footprint of a plant?
Yeah, I think what we have here is what we have seen in the HIPPOS, as we mentioned through the presentation, has been applied to as technology. It comes out from actual plant installations, maybe 16 plants over the years of large scale installations, and effectively the contribution for the environment and comes from 2 points really. One point is the energy consumption and being able to, let's say, produce your product more efficiently. And then the second one is irrespective of what you actually do with the end product, as to whether you actually sell it as a lower grade, or you sell it, or you are unable to sell it, and so forth. Waste or off-spec product is something that is undesirable. So that is one of the issues that we have seen. Plants applying the technology, improving their quality index. So if they can actually move their quality index by a couple of percentage points, or then that can have a significant impact. Another thing that we have seen lately is the post-consumer recycle. Let's say the recycle, basically, the European Union, for example, is introducing a requirement to use recycled polymers, recycled plastics, and that becomes an issue of will come into the getting the license to operate rather than anything else. And what we see from that is that you need to be able to track the use of this recycled material into your production in order to be able to justify and show that. And then HIPPOS can also help on that. So we have we touch on different aspects and different sustainability goals. And as I mentioned in passing, all these different things go to contribute to a better ESG score, which as we're seeing more and more, it becomes an important instrument, let's say, in order to be able to secure financing for your company, your plant, and so forth.
Fantastic. That's great. Thank you very much there, Simeon. So I think that draws our Q&A session as well to an end. So thank you very much again to the presenters, to the participants as well. you've joined a special edition webinar hosted by ABB Energy Industries, but being joined by Hyperion Systems Engineering, provider of HIPOS and Hellenic Petroleum. So thank you very much again to Simeon, Nikos and Simon for joining us for this presentation today. And I hope you can join us at one of our tech talks in the future. Thank you very much.
Thank you. Thank you, everybody.